In this lesson, we are going to go over solving exponential equations. This is part 2. In the first lesson, we talked about what exponential equations are, which is where our variable is in the exponent. And we talked about 2 ways to solve. The first way is to make our bases the same, because then we can use the base exponent property by equating the exponents. The second, if we couldn't get the bases to be the same, we use logarithms in order to solve. So in this lesson, we'll continue on using logarithms to solve exponential equations. So a couple things to remember. Exponential equations are equations with variables in the exponent, and when we're solving for the variable, we want to find the value of the variable that makes the equation true. We also talked about the logarithmic equality property, where if we have logs with the same bases, the expressions inside must be the same. This property also allows us to take the logarithm and use of 2 sides and use properties of logs in order to solve. Okay, and then we also had some properties that we found helpful in order to solve exponential equations using logarithms. So our first example, solve for x, express irrational solutions in exact form and as a decimal rounded to 3 decimal places. So we have base 4 and base 5, and those don't talk to each other. We can't make them the same using powers that we know. So in order to solve this, we'll take the log of both sides. So we have log, this is base 10 of 1 minus 4x equal to log of 5 to the power of x. Now using the power rule, what we're able to do is the exponent is able to come down in front so that we're able to solve for x. Now we have to be very careful. 1 minus 4x is the entire exponent. The entire exponent gets multiplied. So in order to denote that, I would keep it in parentheses as 1 minus 4x. This is times log 4 equals x times log 5. Now in order to solve, we need to distribute to see what we have. So we take 1 times log 4, which is log 4, and negative 4x times log 4, which is negative 4x log 4. This is equal to x log 5. Okay. So now what we need to do, since we're just working with x to the first power, we can solve this like we would a linear equation where we need to get our x's together. So we add 4x log 4 to both sides. Okay, now these don't combine. Log 5 and x log 5, 4x log 4 doesn't become one thing because we have 5 on the inside of one and 4 on the inside of other. It's like adding apples and oranges, okay? You just have apples, you just have oranges. So on the next slide, I'm going to write what we have. We have log 4 is equal to x log 5 plus 4x log 4. Now we have x's in both terms, so that means that x is our greatest common factor that we can take out. So we're going to take out an x from both. So then we have log 5 plus 4 log 4 is equal to log 4. Now x is being multiplied by this entire expression. Okay, log 5 plus 4 log 4 is some number. We don't know what it is yet, but when x is being multiplied by a number, we can divide that by that to get x by itself. So we're going to divide each side by log 5 plus 4 log 4, divide by log 5 plus 4 log, or 4, not 4x, 4 log 4. Okay. So now what we have is we have x is equal to log 4 over log 5 plus 4 log 4. We can continue to use properties of logs to get the denominator at least down to 1 logarithm. Okay, but this is our solution in exact form. Now, to put this in the calculator, we have to be very, very careful. Okay, we have to tell the calculator what the numerator is and what the denominator is. So when you put this into the calculator, I recommend putting parentheses around the numerator and parentheses around the denominator, because you have to tell the calculator what's what, and to do that is using parentheses. So if we do parentheses log 4, close them, divided by parentheses log 5 plus 4 log 4, I get 0.193762 and so on. Our instructions say to round to 3 decimal places, so we go to the 3rd decimal place. The number next door is bigger than 5, so this is equal to 0.194. So that 3 rounds up. Okay. Next, example 2, solve for x, express your rational solutions in exact form and as a decimal rounded to 3 decimal places. So we have an exponential equation. Our variables are in the exponent. We have base 8.2 raised to the power of x, 0.9 raised to the power of x, and those bases don't talk to each other. So we'll take the log of both sides. So we take log. Okay, so we have log 8.2 to the power of x is equal to log 0.9 to the power of x. Using the power rule, the x can come down in front. So x log 8.2 is equal to x log 0.9. Now remember that x is one value. So we have x times some number plus x times another number. The only way that these are going to be equal to each other is if x is equal to 0. But if we were to continue solving, I'll show you what will happen. So we can get our x's to one side. So we have x log 8.2 minus x log 0.9 is equal to 0. If we take out x, this is equal to 0, so x has to be equal to 0. Or if you divide both sides by log 8.2 minus log 0.9, 0 divided by that is still going to be 0. So the answer here is 0. Okay. Next, so solve for x. So we have e raised to the power of negative x is equal to 2 to the power of 4x. We have base e and base 2. Those definitely don't talk to each other because e is an irrational number. But since we have e in this case, I'm going to use the natural logarithm. Okay, you can still use the common log. I just would like to show you what happens when we use the natural logarithm. So we take the ln of both sides. So we have ln of e to the negative x is equal to ln of 2 to the power of 4x. So using properties, negative x can come in front, 4x can come in front. So we have negative x, ln of e is equal to 4x, ln 2. Now the ln of e, if you remember, is just 1. So this is negative x is equal to 4x, ln 2. Okay, so we get our x's together so that we can solve. So I'm going to add x to both sides. So I have 0 is equal to 4x ln 2 plus x. Okay. So again, we factor out an x. So we have 0 is equal to x times 4 ln 2 plus 1. And this gives us x is equal to 0. Okay. Again, you could divide both sides by 4 ln 2 plus 1, but 0 over any number is 0. Next example, solve for x, express irrational solutions in exact form, and as a decimal rounded to 3 decimal places. So we have 321 minus 117 raised to the power of x is equal to 0. So we have we have 117. We can't make 321 into a base of 117 with an exponent, so we will take the log of both sides, but before we do that, we should get one term on each side. So I'm going to add 117 to the power of x to both sides, and this gives me 321 is equal to 117 to the power of x. Okay, so now I can take the log of both sides. So I have log 321 is equal to log 117x. This power rule is coming in handy. X comes down in front. So we have log 321 is equal to x log 117. So to solve for x, we divide by log of 117 on both sides. And we get x is equal to log 321 over log 117. So this is the exact form of the solution, and then we can plug it into our calculator to find the decimal. So we do log 321 divided by log 117. Okay, if you use the natural logarithm or if you're curious, plug both into your calculator and you'll see that they're the same. So this is giving me 1.211934. So we're rounding to 3 decimal places. So this is 1.212. Okay. So the last one that we'll talk about, solve for x. So we have 2 to the power of 2x plus 5 times 2 to the power of x equals 24. So notice that this power is twice, it's got the same base, but it's twice the power of x to give us 2x. Okay, it's also kind of looking a little bit like a quadratic. So if I write this as 2 to the x squared plus 5 times 2x is equal to 24, if I make a substitution of u is equal to 2 to the power of x, I would have u squared plus 5u equals 24, which gives us a quadratic that we know how to solve. So we'll solve for u and then go back and say we have 2 to the x is equal to whatever we get for u. Okay, so we start by subtracting 24 from both sides to give us u squared plus 5u minus 24 equals 0. We look for two numbers that multiply to 24 and add to 5. So we have u plus 8. U minus 3 is equal to 0, which gives us u equals negative 8 and u equals 3. Okay, now we're not done here. We can't just circle this. Remember that we made a substitution. So we have 2 to the x is equal to negative 8, and we have 2 to the x is equal to 3. So for 2 to the x equal to negative 8, we can't raise 2 to any power and get a negative. Okay, even if we raise 2 to the negative third, that's 1 over 8, not negative 8. So from here, we don't get an answer. Okay, but we can look at 2 to the power of x is equal to 3. We can take the log of both sides. So we have log of 2 to the x is equal to log 3. Our favorite power rule coming in handy. Okay, and then we can divide both sides by log 2. So the answer here is x is log 3 over log 2. So that is our final result for this problem. Thank you for watching. If you have any questions, feel free to reach out to me.